Chapter 3 looks at data collection and experimental design. And when you do any statistical study, the goal is to collect the data and then use the data to make decisions. So this isn't going to be like we're on a road trip and we're just going to count how many yellow cars because we want to see how many times we get to do whatever. Maybe play the road. Growing up, I used to play this road trip game with my brother called Banana Splat. And anytime you saw a yellow car, the first one that would say Banana Splat, like, gets a point or whatever. So this isn't you're just doing that to do it. Now that we're older, if we're going to collect data, we're going to want to do something with it. I mean, maybe you do still play games on a road trip just because it's something to do. But anyways, I'm not going to go ask the whole school, hey, do you like the dress code? Just because I'm bored and want to go bother everybody. I want to do something with it. So any decision you make using the results of a statistical study is only as good as the process used to get the data. You may have heard the phrase garbage in, garbage out. If your data is garbage, your decision will be garbage. So the process for this, whether it's a study or an experiment, we have to identify the variables in the population. Determine how we're going to collect the data. And when we do this, we want to make sure the sample is approximately distributed like the population. For instance, going off of that dress code example. Y'all as seniors, I know most of y'all are seniors, not everyone, but most of y'all are seniors. Do you think y'all would have the same opinion of the dress code as a freshman would? Probably not. Possibly, but as some of y'all maybe, you know what, I don't care about the dress code, I'm just going to survive 4 more months without getting dress coded, and then I'm out of here. Freshmen may be like, no, this dress code has got to go. I'm tired. I don't want to do this for 4 years. I can't do this for 4 years. So if you took a sample of just seniors or just freshmen, that's not going to accurately paint the whole picture for the whole school. So once we determine how we're going to get this data, then we have to actually go collect the data. Then we describe it with descriptive statistic techniques. That may be like finding the average, finding a proportion, looking at a graph, something like that. Interpret the data and make decisions, and then identify any possible errors. So those are your 6 steps in this process. Let's look at the different types, whether it's a study or an experiment. In an observational study, a researcher observes and measures characteristics of interest of a part of a population, but does not change the conditions. That would be like our dress code example I've been going with. All you're doing is asking them if they approve of the dress code or not. You're not like, one group. You're not changing anything. You're just observing. An experiment is when a treatment is applied to a part of the population. And we call this the treatment group, and then the responses are observed. The control group has no treatment applied, but in many cases they are given a placebo. Like if you're dealing with medicine in the medical field, they might give them a placebo. which is a harmless fake treatment that's made to look like the real thing. Now, I use a medical example as a placebo, but it could be something like maybe you're wanting to see if those who drink Dr. Pepper have superpowers. I don't know. I'm making this up as we go. But let's say that you're wanting to see, those that drink Dr. Pepper, they gotta have superpowers. They can predict the future. So one group you give Dr. Pepper to, the other group you give Mr. Pibb. But somehow you make it taste like Dr. Pepper so they can't tell. You gave me an off-brand of Dr. Pepper. Get out of here with that crap. And then you see how they react to it. You're changing a variable. Okay, so for this first example, we have to determine whether the study is an observational study or an experiment, and then we have to explain why we say that. The researchers conducted the study to determine how confident Americans are in the U.S. economy. To perform the study, researchers called 1,000 U.S. adults and asked them to rate current U.S. economic conditions and whether the U.S. economy is getting better or worse. So what do we think? Observational study or an experiment? Observational study? What made y'all say that?
They're just asking questions, not conducting any experiments.
That's right. So, observational study. Asking questions. Not changing treatments. Okay. Questions so far? Okay. Let's look at collecting data. So, a couple of ways to collect data. One way is to do a simulation. A simulation is a mathematical model used to reproduce the conditions of a situation or process. A very good example of a simulation that you'll remember is what we did the first day. That smelling Parkinson's activity. That was a small scale simulation, but still, it's a simulation. We didn't have the actual 12 shirts. We just had cards and we basically guessed whether or not the card said Parkinson's or no Parkinson's. Another way of getting data is a survey. A simulation will save you time and money because you don't have to go out and gather the data. But a lot of times we end up doing surveys. So we do an investigation of one or more characteristics of a population. And you're like, but what if I just ask them one question? That's still one or more characteristics because you record their answer. And then, for instance, if we're, again, going back to that dress code example, maybe you also record if they're male or female, or what grade they're in, their demographic, or ethnicity, just whatever you can think of to record. Whether they have long hair or short hair, I don't know. Okay, so sampling techniques. We can do a census. A census is a count or measure of an entire population. The U.S. does this every, anyone know?
10 years?
10 years. Every 10 years. Why do you think they do it every 10 years and not, let's just say, every year? Or every other year? Takes too many resources. Doing a census is very expensive. They hire people to go door to door. Hey, you didn't send in your census response. We're here to collect the data ourselves, basically. And by law, you have to give them the information. So since a census is expensive, we often do sampling. So sampling is a countermeasure of part of a population. But it must represent the population. Okay, so then we have a random sample. A random sample is one in which every member of the population has an equal chance of being selected. So if I were to randomly pick someone in this class as part of my sample, everyone in here has to have the same chance of being selected. Which means I couldn't really pick because what we learned yesterday. We're biased. So maybe I did like a random number generator or something and let the calculator pick. Everyone has an equal chance. A simple random sample is a sample in which every possible sample of the same size has the same chance of being selected. So the difference in those two is like, let's say I'm going to pick 3 people in here randomly. Well, a simple random sample would mean every single possibility of 3 people that I could get would have the same chance. Not that each person has the same chance of being picked, it's that each group of 3 has the same chance of being drawn. Does that make sense? So just be careful when you think about these two. Yes, a simple random sample is a type of random sample, but it's that every possible sample of the same size has the same chance. So there's different ways to do this. The easiest way would be to like assign each data point a number and then use a random number generator, like our calculator for instance, to select the data that we want. Like yesterday where we told the calculator to pick 20 random words. We gave each of those words a number, or we didn't do it. Whoever made that worksheet did it. I didn't even make it, but anyways. Whoever made that worksheet gave each number, saying it backwards, each word a number, and then we just went and we picked 20 numbers and said, okay, these 20 are the ones I want. That's how you can do a simple random sample. So we did that yesterday, we just didn't know it was called that. Okay, the next type is a stratified sample. A stratified sample, stratified guarantees that members of each group within a population will be sampled. So like let's say I have some people here, let's say these are going to be your obnoxious freshmen Fresh meat. Ooh-ha-ha. Freshmen. Here's the sophomores that aren't much better. Then we've got the juniors. They're getting there. They know a lot more than the freshmen and the sophomores, but they're not quite to the status of the seniors yet. Sorry, juniors. And then we have the seniors. If you want to draw, I'm not going to do it on mine, but if you want to draw like crayons on the seniors, go for it. They think they roll the place, but that can be deceiving. Do y'all really? Okay. Stratified means like I would pick, in this case since there's just 3 of each, I would pick one of each. Maybe I want one freshman, one sophomore, one junior, one senior. I'm picking randomly. We want to do a stratified random sample. I'm randomly picking one from each group to survey. That way, if I'm doing like something like dress code or maybe the cell phone policy or whatever the case may be, I make sure that I get some of each grade level. If the population falls into naturally occurring subgroups, and each subgroup itself has similar characteristics, then we can use something called a cluster sample. And these sound really similar. That kind of sounds like stratified, Mr. Schultz. Well, let's say, I'm just going to kind of draw, let's say this is the school. So, I'm not an artist, but let's just say our school looks like a rectangle. And I'm not going to try to really draw our school. And these are classrooms. A cluster sample would be like saying, okay, I want to pick 3 classrooms. One. Of course, you would do this random. I'm just, quote unquote, randomly picking 3. But then, you would survey all the people in that room. It's like you're Gandalf and you're standing at the door. You shall not pass. Unless you answer my question. So you're sampling everyone in that room. So, as an example, good luck tonight. We're going to pick 3 rooms and sample everyone. In the room. Okay. Here's how you can keep stratified and cluster like separated in your mind. Here's like a little memory trick. For stratified, what did we do? We took some people from all the groups. So you can remember this as sum from all. But then for cluster, what did we do? All from some. I picked some rooms, but then I sampled all the people in there. So cluster is all from some. Stratified is some from all. Cluster is all from some. The next type is a systematic sample. This sample, we would order the population. Maybe I order all the high school students alphabetically. And then select members of a population at regular intervals. So this one doesn't really have a nice picture to go with it. So we're just gonna kind of write out an example, like of how we would do it. So order everyone alphabetically. And then we would, let's say, pick a random number between 1 and 20. Step 3, we would survey that person and every 20th thereafter. Okay. So what this is saying is, let's see. I know this won't exactly be random, but what's someone's favorite number between 1 and 20? 3. Okay. So I would survey number 3. And then I would survey number 23, 43, 63, 83, and just keep going down that list until I got however many I needed. If I needed 50 people, I would just keep going down that list until I got my 50 people. And then the last type that we're going to look at is convenient sampling. This is where members of a population that are easy to get are surveyed. It often leads to biased studies. Think of it like you're the superintendent and you want to know if the community supports building a new football stadium. So you're going to go to the next home game and just stand at the gate and survey the first 100 people in the gate. Do you think their views accurately represent the whole community? No. No, why not?
Because they're the ones who go to the football stadium more often than the rest of the community.
Exactly. They're at the stadium. They're going to a game. Like, yeah, I think we need a new stadium. You have someone who never goes to a football game. They're like, no, why are we spending that money? So, convenient sampling often leads to bias. But yet, a lot of people do it. One thing I wish we talked about, and we kind of will on this next example, I just wish we gave names to it, was the different types of bias. We cover it in AP Stats, but we don't really cover it much in here. Okay, so you're doing a study to determine the opinions of students at your school regarding stem cell research. Identify the sampling technique you're using when you select the samples listed. Discuss any potential source or sources of bias, if any. Okay, so for the first method, we're going to divide the student population with respect to major, and then randomly then we select and question some students in each major. So what kind of sample do we think this is? Stratified? What made you say stratified?
Cause it's like, you like put them into groups and.
You choose some from all. Good. So we do it with respect to major, and then we get some in each major. So some from all. That would be stratified. Okay, so there's our type. Now, what could be a possible source of bias for stratified sampling? Think of like how could people possibly skew the results?
They could ask more people in one major than other majors.
Okay, ask more people from one major. So maybe we ask biology majors more than we ask music majors. Ask more from one major than another. Maybe more bio. But well, I still got some from all. I still asked the music majors. Well, yeah, you asked 2 music majors and 300 biology majors. Good job. And y'all may throw tomatoes at me for saying this, but being a bit stereotypical here, biology majors probably have a stronger opinion about stem cell research than music majors have. So they're likely to bias the response. Okay, let's go on to the next example. You select students who are in your statistics class. What kind of sample would that be? Convenience? What made you say convenience?
They're in statistics class right now, so they're easy to get.
That's right, they're in our class, they're easy to get. You can get up, walk around the room, ask them, and then boom, there's your sample. So, how could this bias our research? What's that? They're not well informed on the subject. Okay. Possibly not well informed.
That could be a friend.
Okay, that's another one. Could be all your friends. Do we think it would be representative of the whole population? No. These are all ways we could be biased. Next method. Okay. We assign each student a number and generate random numbers. You then question each student whose number is randomly selected.
Simple.
What made you say simple?
It's just a simple.
It's just a simple way? Yeah, that's one way to look at it. Simple random sample. We're giving them a number, we're saying generate random numbers. Boom. Okay, I'll go ask these people. Done. Okay. Now we have to think of. Actually, I'm not going to make us think of really a way to bias, although we could list tons of them. A big one that I'm going to kind of throw out there is not exactly related to how we pick the people, it's the wording of the question. We're saying could bias the answer. So now, assuming the question isn't like worded badly, this could be a valid, like this could be the best one out of all of them, honestly. Bless you. And an example I'll give on this, not necessarily about stem cell research, but there's an AP question, and I know y'all are dual credit, but I just like how AP like really drills down into it. There's an AP question that gave this as an example. It says, explain how this question is biased. Given the fact that we are in a $40 trillion deficit, do you support us sending money to Ukraine? What's wrong with that question?
It started off with factual information that could bias their answer.
That's right. It started off with factual information that could bias the. I mean, it already sets a negative tone for that question. We're in a $40 trillion deficit and we're sending money somewhere? No, we don't need to do that. So, to kind of neutralize that question, maybe we say, what are your thoughts on sending money to Ukraine? I didn't give a negative spin to it. I didn't give a positive spin. I just said, what are your thoughts? Or if you wanted a yes-no question, you could say, should we send money to Ukraine? Yes, no. We didn't plant any word in their head. If we go back to the stem cell example, do you think stem cell research is good? What word did you just plant in their mind? Good. One place that, or not one place, but a group that is bad about doing this is when you get those surveys after you go to like a store or a restaurant. Did you experience satisfactory service with us today? And it's like you rate it on a scale of 1, not satisfied, 5, very satisfied. Well, they just planted the word satisfactory in your mind. Because they kind of want you to say, yeah, I experienced good service in here. I mean, if everyone starts saying, no, I had terrible service, well, now I've got an issue. So, me personally, I kind of delete those emails when I get them. Like, rate your experience with us today. Delete. You don't really want me to say I had a bad experience. If I did. If I had a good experience, oh great, he had a good one. Okay, whatever. So, I will say, there was I don't remember if it was a restaurant or what it was, but I actually did respond to one because I did not have a good experience. And they reached out to me and like, we are so sorry. We have dealt with it, like here is, we're sending you an e-gift card for the value of your purchase, blah, 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 blah. So they basically comped everything. That wasn't my intent, but I'm like, oh, somebody reads these and actually cares? I'm shocked. But anyways. D, we select a class at random and question each student in the class. This would be cluster. Because we select a single class, but then we get everybody. So we got all from some. How can this be biased?
It's not very representative of the school.
It's not representative of the school. Okay. How else? Kind of going along with that bad example that you probably don't like me using, but I'll use it anyways because it exaggerates the point. If I selected a biology class, would that yield different results than if I selected a theater class? Quite possibly. Yes. So, why? Why is that? Certain classes may know more on the subject than others. And then looks like we actually will finish it today. Last one. We assign each student a number, and after choosing a starting number, we question every 7th student. This is systematic. The issue with systematic samples is that if a particular pattern exists, then in the data, then it can be biased. So like if every 7th person was a female, just by chance, we didn't know that, we didn't plan it, but we're like, oh, what are the odds? Then the data could be biased. Again, as an example, I would say like every 7th is female. Questions on anything today? Did I make anyone mad today with my comments? Good. That means I have to try harder tomorrow.